Right, so I'm going to move on to some packed addition and subtraction instructions now. So here we've got, for example, PADD, PADDS, and PADDUS. All of them have these suffixes on them to say what the element size is. So for example, B is that we're doing byte integers, W is that we're doing word, D is double word, and Q is Q word. So if I just move over to the tests for these, we'll go to Encoding ASM, and we'll start with PADDB. So this is the legacy encoding, and I'll be ignoring these MMX encodings, just like I did with the other instructions, because I'm not going to bother supporting those. But moving down here to these legacy instructions, we've got PADDB, with RM as the operand encoding for this. So we do XMM0, XMM1, and then a memory access. Then we've got a VEX version of this, where VEX pretty much always just has an extra operand, so we'll just put that in there. So VEX here has 3 operands which are in RVM encoding, and there's no sort of broadcasts or anything, or op masks or anything in VEX, but this goes up to YMM for each of them. So we'll just make a copy of this one and change this to YMM. Then we've got EVEX down here. So EVEX starts here with VPADDB. This supports op masks and zeroing masks, and then we can see as well that these double word and Q word versions also support a broadcast. So we can basically just copy all of these and put an op mask and a zeroing mask on them to force the EVEX encodings. And then we'll do another one where we will just add ZMM for this. And this one is the byte version, so it doesn't have any broadcast. We've got the same thing for W. This one also doesn't have any broadcast. The D version, so double word, does have a broadcast, so we'll just make a copy of each of these. And in this case, double word is a 32-bit element size. This will be 1 to 4 because 32 bits will fit 4 times into the XMM register. In the YMM register, it will fit 8 times, and in the ZMM register, it will fit 16 times. Then we'll just take a copy of these. This now changes to Q. And because we doubled the size of the element, we have to halve the number of lanes that it gets broadcast to. So let's just check that. That seems to be okay. Let's just go to the other ones in case they're similar forms. So we've got PADDS as well, which looks like we've got SSE2. So this is B and W. So there's no D or Q here, which means that there's no broadcast in the EVEX versions, but there are the op masks. And then USB looks the same as SB. So I think we can just take, let's just go and take these tests here. We'll change ADDB into, or maybe I shouldn't change it ADDB, I should just change PADD into SB here. It's got the same operand encodings, so I think that's actually all okay there. Then for this one we'll do SW, which should be the same. And then we'll add the next test, which will be changing PADDS into PADDUS. So let's just try and reassemble. There's no Q, yes, I've copied Q somewhere. PADDSQ. Yeah, okay, this should not be, this shouldn't have the S. Okay, so the SB, SW, USB, USW. Okay, that seems like it's okay now. So that's the add ones. Let's just go and see what the sub ones are like, because I imagine they're going to be basically the same. So we've got sub. Well, this is only B and W. This is sub SB, this is sub B. Oh, this one does have D in it. Is there a sub Q? Yes, there is. Okay, let's just, we'll take this one and this one. It looks like it should basically be the same though. So I'm just gonna copy all of these and change add to sub, and we'll just see how that goes. So this becomes sub. Let's just try and assemble this. Okay, I think it's all right. Okay, let's just take all of these. Split into lines, we'll get rid of the empty selections. Okay, let's just transform these into like the test notation and align them all. So I think this all looks okay. We just need to make sure that the broadcasts are in there. Yeah, the broadcasts are okay as well. Okay, let's just reassemble this and we'll go and add the mnemonics. So let's just take all of these mnemonics here. All the way down to here. Let's go to the encoder, or let's go to mnemonic. I suppose I'll just add them here. Okay, let's just deduplicate these, and we will change this to split them by add and sub, just so I can see a bit better what's going on. Maybe we'll split with US and S, VP add. Then we've got sub here, which goes down to there. We got sub S. Okay, I think that's all right. Okay, let's take these down to the name table. And create a name for each of them. And now we'll just add them to the forms. So we got add, let's just go and add them below here. I'll just split these up again. Okay, so let's just do a go test. Right, okay, let's do the add ones first. So let's just go back to my bookmarks here. So we've got add, this is PADD. So we'll go to PADDB first. So the SSE2 legacy encoding, we're just matching on X word here for all of them, really. Because the mnemonic itself has the suffix to describe the element width, I'll just match on the size of the vector register. So here we'll do width is X word, op n for this one is op nrm, op 1 can be vec, op 2 can be vec or memory. The prefix for this is 66. It has the secondary opcode map, and the opcode is FC. Okay. Now let's just go and add family vex for this one. This one can be X word or Y word. And the vex encoding has the same stuff with the same opcode, so that's all okay there. And then we just need one for evex, where this byte one supports op mask and zeroing. Let's just check that that actually does all of it. So it still says that it can't match for VP-ADB. Oh, that's because I need to change the operand encoding. This should be our VM, which means that op2 is actually just a vector, and op3 is the one that can take the memory. VP add B. So we've got op1, op2, op3. This needs to be Z word as well. Okay, that looks like it's all okay. So evex here can only support broadcast on D word and Q word. So I don't need to add any broadcast support for B or W. So this one I think is fine as it is. Let's just take this one and change this to W. So this just went up by 1, so this is going to be FD. And that's basically exactly the same there. Then we've got this D version where it changes up again. So we've got FD goes to FE. Yep, that looks okay. So with D though, we allow broadcast in the memory. Okay, so now we're on to add Q, which is basically going to be the same thing. But this time I think it was D4. So we've got D4 for all of them. Okay, so let's just change the opcode here to D4. Okay, and Q probably has like W bit set maybe, or something like that. Yeah, W is 1 for evex. So here we'll do W is W1. Okay, so now we're on to the SB version. So this one is the signed saturation. So here we've got the same prefix, the same opcode map. The opcode itself is just changing to E instead though, so we've got EC and ED. So let's just go and take PADD, B and W. And then we'll just change PADD into ADDS, and we'll change the opcodes from 0xF into E instead. Okay, so now we just need USB. And the USB version is more of the same, but the opcode is starting with D instead. So we'll go and take this 0xe and change that to D. Okay, so now it's onto the sub instructions. So we can basically just guess that it's going to be the same as these ones, just with some different opcodes or prefixes or something. So we'll just change PADD here into PSUB. This should match everything, but output the incorrect bytes. So now let's just go and find PSUB again. So we've got PSUB. PSUBB and things like that. So this one is still 660F, but it's F8 and F9. So this one is F8. This one's going to be F9. And this one's going to be FA. The Q version is FB. Then we've got the SB and SW ones, which are just changing to E. So these ones are E. Yeah, okay, so these change to E9. This one's probably going to be EA. And then this is probably going to be the same thing, E9 and or D9 and DA. Okay, so that's sub SB got E9, but it wants E8. So is sub SW okay, or no? Okay, I've just gone up one, I've just gone up one too many, so this is E9 here. And the same problem here as well. This should be 8, and this should be 9. Okay, so that's some simple packed addition and subtraction instructions.